Hello everyone, welcome to this video. In this video, we shall be looking at another question from group theory. So we have been talking about dihedral groups. We know rotation followed by a rotation is a rotation. Reflection followed by a reflection is a rotation. Now what about rotation and reflection, or reflection and a rotation? So here we need to explain geometrically that why a rotation and a reflection taken together in either order must be a reflection. So we need to take this thing. So here also let's take the case of N3. For N3 we have the dihedral group of equilateral triangles, correct? So in the Cayley table we can clearly see, if we take the reflections first and then the rotations, the resultant would be this square which I have marked with a black dotted line, right? So in this square all L1, L2, L3 they represent the reflections. Similarly, if you consider the rotations first and then the reflections, you would have this as the final outcomes. Again, the final outcomes, they are reflections. This is according to the Cayley table. However, we need to suggest the result in general. So in general, we already know that for dihedral groups, which represents the group of symmetries of polygon, each rotation is orientation preserving. So that means what do we mean by that? So suppose we have this pentagon. So let's call the vertices as 1, 2, 3, 4 and 5. Correct? Now we are rotating it in clockwise direction. This is our aim here. So here each rotation, what does it do? It preserves the orientation. So that means one would be the element which is coming before 2, 2 would be the element which is coming before 3 and so on. So that means this order would not change, this orientation would not change, however their positions would change, right? That is the number of vertices of a polygon 1 to n in clockwise order, they remain in clockwise order, their order does not change while rotation. Whereas in reflection, the orientation reverses. That means suppose we take we again draw this pentagon, right? Again name the vertex as 1, 2, 3, 4, 5 in clockwise direction. Let's now take reflection along this axis. So what it will do, it will in effect keep 1 as fixed, 2 would come here, 3 would come here, 4 would come here and 5 would come here. So that means you see the orientation was previously clockwise, now it has become anti-clockwise. So it has reversed the orientation. So each reflection is orientation reversing. So that means the number of vertices in clockwise order will then become anti-clockwise in nature after reflection. So what would be the effect of a rotation together with a reflection? So the result would automatically be anti-clockwise direction, right? That would be the result. So therefore a rotation and a reflection, when they are taken together, result in a single orientation which reverses the group action, and that is reflection. And this is what we wanted to show here in this question. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.